Good afternoon, everyone. This is Laika together with my groupmates, and we will be discussing about the climate change, the inconvenient truth. We divided this topic into three parts, which are the impacts, mitigation, and the ethical dilemmas of nanotechnology. So I will be the one to discuss about the impacts of climate change. Now let us define first the climate change. What is climate change?
So, climate change refers to a long-term shift in global or regional climate patterns. Often, climate change refers specifically to the rise in the global temperatures from the middle 20th century to present. So, the cause of current climate change can be accounted largely to human activity. The human activities that contributed to climate change include burning fossil fuels like natural gas, oil, and coal. Did you know that burning these materials releases greenhouse gases into Earth's atmosphere? Now let us know how greenhouse gases actually work.
The Earth and the Moon are basically the same distance from the Sun, yet temperatures on the Moon average an unlivable -18 degrees Celsius. And even deadlier, they range from -170 Celsius during lunar night to 100 Celsius at lunar noon, regularly exceeding both the coldest and hottest temperatures ever recorded on Earth. And while the days and nights on the Moon are about 14 times longer than those on Earth, our planet's relatively fast rotation isn't what spares us from those loony temperatures. What protects us is our atmosphere. By day, it serves as a shield, blocking out the most harmful and energetic of the Sun's rays and about 1/3 of the less intense but visible light. At the same time, it traps the infrared radiation, aka heat, radiating out from Earth's sun-warmed surface, keeping us from freezing solid at night. In order for our atmosphere to absorb any kind of radiation, it needs to have some electrically charged particles for passing electromagnetic waves to push around. And most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the Moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder.
Climate affects nearly every aspect of our lives. From our food sources to our transport infrastructure, from what clothes we wear to where we go on holiday. It has really a huge effect on our livelihoods, on our health and our future. We know our climate is changing due to humans, and these changes are already having a big impact on our lives. That's why it is important to understand how climate is changing so that we can prepare for the future. Now these are the impacts of climate change. The first one is water. Changes in our water resources can have a big impact on our world and our lives. Flooding is an increasing issue as our climate is changing. Second is the food. Our food supply depends on climate and weather conditions. Although farmers and researchers may be able to adapt some agricultural techniques and technologies or develop new ones, some changes will be difficult to manage. Did you know that increased temperatures and water stress, diseases, and weather extremes create challenges for the farmers and ranchers who put food on our tables? The third one is human health. Climate change is already impacting human health. Changes in weather and climate patterns can put lives at risk. We know that heat is the most deadly weather phenomena. As ocean temperatures rise, hurricanes are getting stronger and wetter, which can cause death. It is sad to know that human farm workers can suffer from heat-related health issues like heat stroke and heart attacks. Next is the environment. Climate change will continue to have impact on ecosystems and organisms. Increasing and changing precipitation patterns stress ecosystems. So we should take good care of our environment before it's too late. The last one is infrastructure. It includes bridge, roads, ports, electrical grids, broadband internet, and other parts of our transportation and communication systems. Extreme weather events that bring heavy rains, floods, wind, snow, or temperature changes can stress existing structure and facilities. So again, these are the impacts of climate change. But we can limit the impacts of climate change. Let's make a difference. Everyone can help limit climate change, from the way we travel, to the electricity we use, and the food we eat. So right now, I hope you make a difference. Let us be more responsible in everything we do. It won't just impact forest, coral reefs, or even people. It will affect all of us. So right now, let's be more responsible and let's save the earth. That is the end of my report. Thank you for listening.
I'm Romana E. Gutierrez, the second reporter. Mitigation of climate change. Mitigation, or reducing climate change, involves reducing the flow of heat-trapping greenhouse gases into the atmosphere. It is thereby reducing sources of these gases, for example, the burning of fossil fuels for electricity, heat or transport, or enhancing the sinks that accumulate and store these gases, such as the oceans, forests, and soils. The goal of mitigation is to avoid significant human interference with the climate system and stabilize greenhouse gas levels in the time frame sufficient to allow ecosystem to adapt naturally to climate change, ensure that food production is not threatened, and to enable economic development to proceed in a sustainable manner. What does this mean to mitigate the effects of climate change? Climate change mitigation means avoiding and reducing emissions of heat-trapping greenhouse gases into the atmosphere to prevent the planet from warming to more extreme temperature. Can we mitigate the effects of climate change? Mitigation strategies include retrofitting buildings to make them more energy efficient, adapting renewable energy sources like solar, wind, and small hydro, helping cities develop more sustainable transport, such as bus rapid transit, electric vehicles, and biofuels, and promoting more sustainable uses of land. How can we mitigate climate change in the Philippines? This focus on promoting energy efficiency, improving transport system, shifting to cleaner fuels and vehicles management, and wastewater treatment, ensuring forest protection, restoration and rehabilitation, and adapting climate-resilient agriculture practices. What are the 5 ways to mitigate climate change? First, keep fossil fuels in the ground. Second, invest in renewable energy. Third, switch to sustainable transport. Fourth, help us keep our home cozy. And the last one is improve farming and encouraging vegan diets.
Good afternoon, ma'am. Good afternoon, classmate. I am Yuni JP Ortega, the last reporter for this group. My topic assigned is about ethical dilemmas of nanotechnology. nanotechnology and climate change. According to researchers, CO2 negative and CO2 neutral technologies bring hope as they can cause vast economic advantages, but the right political and social support is needed for those kinds of innovations. To help in dealing with the changes in climate, nanotechnology can be used in the following ways.
First, stop subsidizing technology like biodiesel, bioethanol, or biogas. Non-subsidized for left to compete with other technologies which highly competitive though TOHI must have support. Second, invest in disruptive technologies. Investment in the entrepreneurship is required for disruptive changes. These changes seen as a massive support for those countries who did not feel for in terms of technologies and industries based on CO2 dominates. Third, prioritize cheap energy storage. Affordable and cheaper energy is also needed, especially sustainable energy such as water, solar, and wind for the exact purpose of that allows electrical energy reversible storage of chemical bonds. Fourth, promote biomass-based technologies. Biomass promotion is more helpful, considerable, and most affordable in the field of climate change. It helps to keep global warming at a limited degree Celsius of carbon dioxide emission level. And the last, develop oxyfuels. The produced oxygen doesn't need much purification, and solar hydrogen might combine with it to make base of CO2 neutral liquid transportation fuel. In these cases, we determine the good method of converting value including carbon resources, foils, chemicals of high value through the usage of heat sun's energy and using CO2 carrier.
These are the negative impact of nanotechnology in the field of environment. Toxicological studies have shown that nanoparticles have toxic effects on unicellular, aquatic organisms and aquatic animals, such as fish and daphnia. Carbon nanotubes are a limiting factor of growth and protest, and they have toxic effect on the respiratory system of rainbow trout. So here's some of my conclusion on how are we going to help in solving our environmental dilemma. So from saving raw materials, energy, and water to decreasing greenhouse gases and dangerous waste. Nanotechnology's unique attribute can be utilized in various product, procedures, and applications that could undoubtedly support environmental and climate protection. That's all for my part, guys. Thank you for listening, and once again, good afternoon.